Welcome back, everyone. As we continue our discussion on our topic on the program voltage controller, we are now in the unit 4. Our topic is about latching, unlatching, and interlock circuit. In this unit, we'll be discussing the electromechanical relay, latching and unlatching circuit, as well as the interlock circuit. Upon completion of this tutorial, the students will be able to identify parts of an electromechanical relay, describe how a relay is used to perform latching and unlatching operation, differentiate methods of latching and unlatching circuit, describe operation of an interlock circuit, and of course, you will be able to appreciate the importance of using relay. Electromechanical relay. The most important point to understand about relay is that the electrical circuit that energizes the coil is not connected electrically with the contacts. The contacts are moved by magnetic force, so they are electrically isolated from the coil voltage. Typical examples of relay are shown in the picture. So a relay consists of a relay coil as well as the relay contacts. Contacts serves as the as switch, in controlling our load circuit, and coil here is being energized to activate an electromechanical relay, or sometimes called relay. This is the internal connection of the relay. Now, as you can see here, shown in the picture, we have here the coil. Then it is extended outside so that we could connect power here to control a relay. And in this side, this blue side, now we have here the contacts. In this illustration, pin 1 and 2 are the normally connected points, while pin 1 and 4 are the normally open points or contacts. So without activating the relay, point 1 and 2 are now in contacts, meaning they are connected. Then when we activate the relay, the contacts will transfer from number 2 to 4, meaning when you activate a relay, the connection now will transfer between point 1 and 4. So this is how relay is being constructed. Now we have here the relay contact. And we have here the movable arm that is being pulled by the magnetic force here when relay coil is energized. This is also an illustration how a relay would work. This type of relay, we have here total of 6 plus 2, we have 8, 8 terminals. Actually, it is a standard in relay that pin number 13 and 14 are intended for relay coil, meaning you need to power this coil so that your relay will activate. Point or pins number 1 and 9 is normally closed, as shown here in the diagram. And on the other side, pins 8, I don't know, pins 4 and 12 here, 4 and 12 are normally closed, while pin 8 and 12 are normally open. So this is how the connections are being illustrated. This symbol indicates a normally open contact, 5 and 9 in this case. And for normally closed contact, we have 4 and 12 here. 4 and 12 are normally closed. So one thing to remember about relay is that during the normal state, this is the connection. The normally closed are closed and the normally open contacts are of course open. When we activate the relay, meaning we have to supply voltage at the coil, the relay is activated. So when the relay is activated, all normally open contact will close and all normally closed contact will open. As shown here, the contacts here originally from point or pin number 1. So it transferred to pin number 5, and the other side the same. Supposedly original position is at pin number 4 and transferred to number 8, meaning the connection now is pin number 8 and 12, and the other side, pins 5 and 9 are now closed. This is a typical relay device. No, there are several types of relay. No, in terms of the connection. In our example here, we have one, two, three, four. So four terminals. So meaning we have four normally closed contacts and we have four normally open contacts. So normally open contacts would close when the relay is activated, and all normally closed contact will open when relay are activated. So basic relay connections, how we are we going to connect relay to control our load? So in this diagram, we have here a relay that is being connected to control a lamp. It is this lamp is powered by 100 volts supply voltage, and the coil here is being powered by 24 volts. In circuits, no, or in actual application, we call this as your power circuit. The battery here and the lamp. And we have here also the coil powered with 24 volts and a control switch. This is now your control circuit. So we have the power circuit to handle the high power rating current, and we have here the control circuits, which is used to control the current flowing across these circuits. So when we activate the relay, no, the lamp here light up. Because the connection here transfer from normally closed to normally open, since the connection of your valve is at the normally open, so current would tend to flow. Because we have activated here the switch, meaning we have applied the power to your coil, so the relay is activated and the switching is undertaking, meaning your load power is being switched on by your control circuit. So we'll proceed with latching and unlatching circuits. So application of relay classes, it would be easy for you to understand the relay or PLC programming when you will be able to understand how a relay would work. So in here, we'll discuss how relay controls this circuit, no? How relay is used to latch a circuit and how it is also used to, or how it can unlatch the circuit. Actually, when we say latching, just like this ball pen, when you say latch, you press this one, that is latch. And of course, no, if you press another button, it will unlatch, no? So this is what we call latching and unlatching. So here in the diagram, I will be showing you the connection of our circuit. Here we have the switch here, post button switch, a normally open connection. We have also here the contact, which is also a normally open connection. We have here your lamp, and we have here your relay. So again, a relay consists of a coil and a contact. So when you energize this coil of the relay through the switch, so the relay will activate. So what will happen if it will activate? We'll push the switch. Okay, upon pushing the switch here, the power is being applied now to your relay coil. And at the same time, you apply also power for the lamp, because relay coil and lamp are connected in one connection, meaning they are in parallel. On the other hand, this relay contact here, which is originally normally open, now closes, the closure. So meaning it also provides power here. So both switches, the set switch and this contact for R1 are providing power to your relay. What happens if we will release the switch? When we release here the switch, still the relay is energized because it is energized through this contact. Of course, since these circuits are energized, no, and the relay is being activated, your lamp one is also being activated. So this is what we call latching, meaning we turned on the circuit. So of course, no, this is just turning on, but we cannot turn this off there. So we need to provide another circuit for turning off the circuit. Actually, no, cutting the line here, meaning if you deactivate the relay, no, the contacts here will open. But this time, since the relay is activated, Still the contact here of R1 is in contact here that provides power to your relay. There. So we release the switch. Still the power is being, the relay is still activated, and of course the lamp is being powered. Okay. So since latching has no mass application, it was because we cannot turn it off. No, so we devised the circuit. We improved the circuit by providing a reset circuit, no? Reset switch. So if you can see, no, the configuration above here, just similar to what I've shown you earlier, we just added here a reset switch, which is a normally closed contact switch. So this, if you allow to see the connection, your set switch here and your R1 here are connected in an OR function, while your set switch here and your reset switch here are being configured as an function. When we activate the switch set, the circuit turned on. There, releasing the set switch still maintains the relay in active mode. So meaning when even you release the set switch here, this circuit still turns on because of this contact here that is being closed, no? Because the relay here is activated. How to turn this off? So we'll have to cut the power here. Upon pressing the reset switch, which is normally closed, okay, now the circuit's off because there is no way of flowing power here. No way that the power could flow here because both the switches here are open. Even returning the reset switch to its original position will not turn on the circuit. So it will only turn on when, again, the power here is being activated. This is a configuration of an unlatching circuit using reset priority. Because we have two types of set reset circuits. Now we have the priority set and we have the priority reset. In this configuration, this type of configuration is the priority reset circuit. Priority reset, no, because in layman's term, when we say reset, that is off, turning it off, while set is turning it on. Okay, no? So turning, just like this one, turning this on, okay, releasing, then turning off, there. Another type of configuration or connection using the in the unlatching circuit is the set priority. If you could notice here, the connection between set switch and the R1 are the same, but the reset switch here is being connected now here. No? It does not pass over here. But of course, these functions are the same. No, we'll turn this on by pressing the set switch there. Releasing the set switch will not turn it off, but it will turn off when reset switch is activated. There. So we have just discussed, no, the unlatching circuit. There are two ways of using configuring your reset switch. Either you have to connect it here in series with R1 and R1 or set switch, and this that is in this connection, this one is the set priority. Set priority because when we press both switches, kumbaga dunga nun mabitom ok ang set kag ang reset, masiga gini ang bulb mo because the power will tend to flow here. There, no? So that is why we call this as your priority set. While in the other hand, no, the other circuit in above, as I've shown you here, no, when both switches are pressed together, this circuit will not turn on because the reset switch here is open. Take note, we have two types of unlatching circuit, the priority reset and the priority set configuration or circuit. Okay, last topic, we'll be discussing about the interlock circuit. Actually, interlock circuit is just an application of the circuit we have discussed earlier, the latching and unlatching circuit. How it is being applied, no? Because in some industrial application, now we'll be using this interlock circuit. So shown here is actually this is an escalator. If you go to the mall, no, you will see this one. An escalator could be either going up or going down, depending on how the switch is being turned on. So in our example here, if we press this switch down, so the escalator is going down, no? Pressing the switch up, no, would not make it turn up unless you turn first stop. You stop first, then if you want to change direction, you have to press the up button. So this is how an escalator is being controlled. So actually, the escalator could be going up or going down depending on how are we going to program it. But no, you cannot change direction unless you stop first the motor. Okay, I will explain you how an interlock circuit is being made. Here, actually, if you have to take a look here, this is just a unlatching circuit. Unlatching circuit priority reset here. But instead of having a switch here, which is normally closed, we have provided here a contact, which is being controlled by relay 2. And at the same manner, the other circuit here is just a reset priority circuit unlatching, which is the reset switch is being controlled by your R1. And of course, these are just lamp indicator. So to see if which of this lamp is being turned on when switches are being pushed. So we have here two switches, push button number 1 and push button number 2. Take note the configuration. So we have here R1 here, contacts being controlled by this relay. And the R2 contact here is being controlled by this relay. Meaning, this is your relay coil. This is the contact. And for R1, this is your relay coil, and this is your contact. If we push button number 1, there. So the R1 is activated because you have pushed it 1. Since R1 is activated, so the contact R1 here will close, and the other contact for R1 here also closes, making your lamp number 1 to turn on. Oh. See? See? Okay, I will turn it back. Again, I will demonstrate. This is the standard connection. R1 here is normally closed. Now R2 here is normally closed, and R1 here are normally closed. Take note that the contact R1 here is being controlled by this relay. And contact R2 here is being controlled by this relay. So at normal, this is the configuration, meaning when you close this portion here, the circuit will turn on here, there. Releasing the switch, still the circuit is being turned on. Okay. Here, I am pressing here push button number 2. Even the push button number 2 class is activated, there will be no way of current flowing here because relay R1 here, which is normally closed, now open because relay R1 is being activated. So no way of switching this on. This is what we call interlock, meaning once you turned on the motor forward, you cannot turn it in reverse direction unless you stop the circuit first. So meaning i-reset mo na. But I have not shown here a reset switch. So what I'll be going to do is simply to turn off the circuit by removing the power. There. So I remove the power, so all circuits return to standby condition. Okay. Oh, notice that R1 here are now closed because R1 here is not activated. So when I push the push button number 2, there. So when I push the push button number 2, this relay R2 is activated. So when relay R2 is activated, R2 here, which is normally closed, will open. And of course, R2 here will also close and will make will provide power to your L1, and your L1 will tend to light. And notice also that R2 relay coil here is activated, the contact here is also activated. When I release the push button number 2, still the circuit is activated. And pressing push button number 1, this one, no, has no effect. There. No effect because the circuit now is locked, because the normally closed contact here of R2 is now open. So no way of switching R1. Okay? You can simply turn this circuit off by removing all the power there. So with the circuit now is reset and ready for another function. So either you press the push button number 1 to activate the relay 1, or you have to push the push button number 2 to activate the relay number 2. This is how an interlock circuit works. So there are several applications of the circuit. So please study the circuit here, how it works. The discussion here will be included in your midterm exam. So I will be giving a midterm exam online. So I will send you questionnaires. No, probably we'll be using the zip grade. So please review the presentation, and this will be part of your midterm examination. So thank you very much for listening, and have a good day, have a safe day. No, so please be prepared for your midterm examination next meeting. So you can share the video with your classmates, and if you like, then do the liking. So thank you very much. See you in the next presentation. Bye bye.